morning, our virtual friends. We're going to start our lesson for the day, so make sure that you have everything that you need to take your notes, to do your work, whatever you may need at home for you to do our lesson with us today. All right, friends, we are going to continue talking about area. Okay, this week we're going to dig deeper with area. It's still simple because we know that when we try to find the area, we are measuring the what of a shape or object. The what? Tell me. The inside. Very good job. The inside. So once we know, area, we multiply length times width for regular shapes, we can take what we know and apply it and think deeper when we have harder questions asked to us, right? That's why it's so important to get those basic skills so that we can apply them when our questions get a little harder, okay? And that's what we're going to do today. Good thing is we already know the distributive property, don't we? Yes? When did we learn the distributive property? What did we work with on the distributive property when we broke things apart? AJ? Arrays. That's exactly right. Okay? And what have we already noticed about when we have squares and rectangles with unit squares inside of them? We said they look just like a what? An array. So we're good to go, aren't we? Yeah? Yes. Good. Okay. Let's talk about rectangles. All right. This is very important, and we do know this because we have talked about this, but let's refresh our memory. Okay? What do we know about rectangles? Who can tell me what do we know about rectangles that helps us when we apply area? Riley?
The opposite sides are going to be the same.
Okay, say that louder, Riley.
The opposite sides are going to be the same.
Good. Julia, what did she just say? Say it one more time and make sure all of our friends are listening to you.
The opposite sides are going to be the same.
The same what? Good. Okay, what did she just say? Our opposite sides are equal. The length are equal and the width are equal, right? Because that is a characteristic of a rectangle. Kelsey, what did I just say that's so important about rectangles?
Opposite sides have equal sides every time.
Very good job. Opposite sides are what, everybody? Equal. Very good job. What else do we notice about a rectangle? And this is going to play into tomorrow's lesson that's really important. But what do you notice about a rectangle here? Think about the corners here. What do we notice about them? This is new because y'all did not get to geometry in second grade last year. But most of you can tell me squares and rectangles have what? Eliana? Let's look at the corners here.
Squares and rectangles, they both have both sides and both.
4 corners. Okay, we know that. But what about our corners, Emily? All right, we're going to introduce a new vocabulary word today and say angles. Have you ever heard about angles?
Yeah.
Okay, good. So we know that we've always said corners, corners, corners. Let's take that word corner and throw it out the window. Ready? Let's take it. I'm going to throw it out that window right there. Goodbye, elementary language. We are now using good third grade vocabulary, and the word is what? Angles. Okay? These are called right angles. And we're going to talk about angles in our geometry unit. But we need to know they are right. They are perfect. They are just right. Okay? They're right angles. That means that they are very... This marker, I found out that was dead last week, and I still have it up here. Throw this away from me. Oh, that was a great catch. But we had a disaster in the middle of it. Okay, they're just right. That means they are straight. That was not straight. Okay? Boop, boop. They're straight. You can also create a perfect square or a rectangle in the corner. Okay, that's very important for tomorrow's lesson. So are you going to remember that? Yes? Okay, good. So, rectangles, they have opposite sides are what? Equal. Same with squares, opposite sides are equal, but with a square, all sides are equal, right? And I should have put, let's talk about squares and rectangles. They have 4 what type of angles? Right. They have 4 what? Right angles. Yeah, look at us using our vocabulary. Okay, let's see if we can remember that. Alrighty. What shape do we have here? A rectangle. What do they have inside of our rectangle? Units, squares. Very good job. Units, squares. Anytime they do not have our length or our width given to us, they're going to have unit squares in there. Or either they're going to say, here's a ruler, measure it, right? Okay? Because we have to figure out how can we find our length and width, right? Okay, we're going to start with rectangles that have unit squares in them. And then we're going to apply what we just talked about to a rectangle when we don't have anything inside of here. Okay? All right, let's talk about this. What have they done to our beautiful rectangle here? What have they done to it? Alana? Make sure you're on the correct slide, please. They split it in half. What have they done to it? Bryn?
They split the left side of
They done what? They, remember we took our scalpel and we did our distributive doctor? Hey, they cut this apart, didn't they? Okay, they said, hey, I don't want one rectangle, I want what? Two. So they took that red line and they have cut this apart for us. And let's refresh our memory. Do you remember how we labeled them rectangle what? Anybody? Rectangle A and rectangle what? B. Ah, it's coming back to us. Okay, we have rectangle A, rectangle B. That is just for us to see. Oh, I have two rectangles now. Okay, this was way too big. I don't want to have to find the area. I'm going to break it apart and get it smaller. Okay, so we have stopped right here. It's like we have cut this. This all is, pretend that we are spreading apart. This one's over here. We have two separate rectangles here, don't we? Okay, all right. Now, how are we going to have the distributive property of this? Remember, a distributive property took one equation and did what to it? Broke it apart into two smaller. So they took one big array, one big area, and they have broken apart into two smaller areas, right? And what must go in between them? Plus, because we have to add them back together to find our original equation, correct? Okay, what is our original equation? Who can tell me what was our original length and width before we broke it apart? Actually, I'm going to come back to that question. So be thinking about that. I'm going to come back to that question because I just looked at Anna on the screen and I want us to make that connection there, okay? All right, let's label our length and width for A. Our length and width for A. Go ahead and do that, please. This is not a new skill. Everybody better be able to do your length and width for A. Count again. All right, I should see it labeled on your rectangle. That's all I've asked you to do. I see all kinds of work on people's screens. You know you do not work ahead of me. All right, how many down? 1, 2, 3, what? 4. Good. How many across? 1, 2. Very good job. So our length and width for A is what? 4 and 2. All right, let's find our length and width for B. Length and width for B. Remember, we have this red line. Do not cross, right? So we are only focused here and here, okay? You can count down here, but that might get a little confusing, correct? So don't you think it might be easier to count our width on this side? Okay? All right, let's go ahead and do that. Ready? 1, 2, 3, and 4. And across. 1, 2, 3, 4, 5, 6. Everybody have that? All right. How many rectangles did I just make? 2. A and B. So how many sets of parentheses am I going to have? 2. 1 for A and 1 for B. And what must go in between them? Plus, plus, plus. Very good job. All right, we are finding the area. Area we multiply. Length times width. Again, everybody. Area.
Multiply length times width.
All right, A. What is our length times width for A? Chelsea?
4 times
Good. You can do 2 times 4 or 4 times 2. Doesn't matter. All right, and what is our length and width, Coleman, for B?
2. 6 and 4.
6 times 4. Very good job. All right, now let's look over here. Before we work this out, who can raise their hand and tell me, actually, let's do it in order, because remember on the distributive property, we like to see which number is in the same spot each time, right? Okay, so let's do length and width. So that would be 2 times 4. Length and width, 6 times 4. So if you did it like me the first time, fix it. All right, remember the distributive property? They keep a factor and they do what? Break apart a factor. Which factor did they keep? Marley? 4. Tell me one way that you know that they kept the 4. The 4 is in both spots. Very good job. We have a 4 here. We have a 4 here. We see it in both equations. What's another way that we know that they kept the 4? Ethan? Annalie?
Because in a rectangle, opposite sides
Opposite sides are what? Equal. So if this is 4, we knew that what? This is 4. Y'all remember that in a second. Okay, remember that in a second, all right? 4, 4. And it's on our picture. We know that they kept a 4 because it's twice here on our picture, isn't it? Okay? They did not interrupt the 4, did they? No, they interrupted the top. That's a poor try at drawing a bracket. Okay, so what was our original factor up here that they went, oh, I'm going to break you apart into 2 and 6. But when I smush you back together, I get 1, 2, 3, 4, 5, 6, 7, 8. Very good job. Is distributive property coming back to you now? Feeling it? Okay, very easy, very easy, very easy. All right, we do our parentheses first. What is 2 times 4? 8. What is 6 times 4? We should know that by memory. What is 6 times 4?
24.
And what must go in between them? Plus, plus, plus. Add up 8 plus 24, and you better stack it up if you can't do it in your head. If you know what 8 times 4 is, you know what 8 plus 24 is. And what is it?
32.
32. Very good job. So if you went and counted all these squares, you would count how many total squares on the inside? 32. Okay, I'm about to erase all this stuff right here. You keep it on yours. And I want to look at something. Okay. If this was all that I had given to me, would you know what 2 multiplication sentences you would need?
No. Yes.
Okay, I hear a yes and I hear a no.
Yes. Yes.
Okay, Jack, what would be 1? Obviously, A's super duper easy, isn't it? Okay, what would A be? 4 times 2, right? Or 2 times 4, right? 4 times 2. That's super duper easy, okay? What about B? Okay, I see 6, but I have nothing over here. And y'all sitting here telling me, yeah, you got this, yeah! Ethan?
It'd be 6 times 4.
How do you know it's going to be 6 times 4? I don't have 4 right here.
Because the other side is equal.
Because what did we talk about at the very beginning of our lesson? We said opposite sides are what? Equal. Guess what? You'll have to know that on your test. You'll have to know that in about 10 minutes when we get to those slides, okay? If this is 4, we know what? This is 4 if you want to look at it that way, or what? This is 4. Here, look at it this way, right? 4 times 2 plus 4 times 6. Okay? another way, you're gonna see this in just a second, that you will see the distributive property is like this. Okay, they kept the 4 outside because they say, hey, you're going to be multiplying by 4. That is the factor that we kept. We saw that factor 4 in both sets of our parentheses, didn't we? Okay, so they kept it outside because they know that that one appears twice. 4 times, and then they put 2 and 6 in your parentheses. Well, what must go in between them?
Plus.
And we do our parentheses first. What's 2 plus 6? 8. So you're left with 4 times what? 8. Isn't that easy? You know this. 4 times, 2 plus 6 is what? 8. So this is a 4 times 8. Y'all see how simple that is? Okay? You will see distributive like this on your test. You will see it both ways. You have to, which 3 equations equal the area? Well, that would be one of them. So would the other one that we just did. Okay? All right, let's look at the next one. Okay? So sorry about that. All right, let's go ahead. They have cut this one for us, haven't they? And we now have rectangle A and rectangle B. I'm giving you 30 seconds to find the length and width for both of those. That's really all it should take you. I love how everybody's on task. I was really gonna try to call out somebody. Y'all can't catch anybody not doing their work. Good, I like that. That's a good problem to have. Okay. Who can tell me how many down, how many across? What is my length and width for A, Annalie?
Our length and width for A is, our length is 3, and
Okay.
our width is 3.
That means this is a what?
A square.
That one's a square because you have the same length and width. Good, okay? What about the bottom one? What is my length and width for the bottom? Remember, I should not have all 4 sides with a number on it. Am I finding the perimeter? No, I should just have one length, one width. It gets too crazy and confusing when you have all those numbers on there. Okay, Chelsea, what's my length and width for B?
4 and
4 and what?
3.
3. Is it necessary that I write that?
No.
Okay, I am going to write it, but let me rephrase my question. Was it necessary to go count that to know that that is 3?
No.
Because this is a what shape?
Rectangle.
A rectangle. If the top is 3, then the what? Bottom is 3 because opposite sides are.
Equal.
So obviously we know immediately what factor did they keep? 3. So if I see that new way, what poor little guy's going to be left alone outside the parentheses by itself? The what? 3. Okay, very good job. How many rectangles do I have? 2. So how many sets of parentheses am I going to have? 2. Okay, we're just going to put them on top of each other over here because we don't have a lot of room. So we have A plus B. All right. Here are we. And let's go in that order. What is our length times our width for A? 3 times 3. Campbell, what is our length times our width for B? Our length times our width. Good. 3 times 4. Okay. Who can tell me the other way to write it? And I will kind of do this to help you since that is new. Okay, remember the factor that we kept is going to be outside all by itself because you're using it twice for this one and then for this one, right? So who did we keep that's going to be outside our parentheses all by its lonesome, Riley? 3. He's cool. Hey, I'm cool. You kept me. I can be out here all by myself. Okay? And then we're going to just be adding back up the side that we cut through. We cut right in the middle of what 2 numbers? 3 and 4. So when we add those back up, we get what? Hello? 7. I mean, that's really easy, isn't it? Okay? This one helps us solve it, but this one helps us find our original equation really fast, doesn't it? Okay? Alright, over to the side. Let's work on our distributive. We do our parentheses. First, what's 3 times 3? 9. What's 3 times 4? 3 times 4. We should know that like this. 12. And what must go in between them? Plus, plus, plus. And we know that our original equation was 3 times what? Huh? Make that a plus sign. 3 times what? Hello? No, what was this number? 7. Thank you. Remember, we broke it apart. We got to put it back together. We did it right here. We said it was what? 7. Pay attention. I told you this was a lot. Pay attention. Good. 3 times, whoop, 7. Awesome. Figure out 9 times 12. You should know what 3 times 7 is. And what is our answer? Loud. 21. Thank you. 3 times 7 is 21. Remember, I tell you every day, it is important. It's very important, the energy that we put into our work. Do you see me moping around up here teaching you? Okay, everybody. This is the distributive property of area. Would you learn anything if I acted that way? Okay? If I'm giving my energy up here, I need you giving your energy in your seat. Yes, ma'am? We have had that discussion. All right, very good job. So, our original area, or array, was a 3 times 7. So, the area of this rectangle is what, everybody? 21 what? We forgot to label the last one. Square units. Very good job. All right, you're on your own. Oh, well, this one, of course, is different. Let's divide this one right here. Cut. Shorter. All right, go for it. Good, Marley. Good, Henry. Good, Ethan. Hey, you've got to have them all labeled before you start doing that. Ethan, I want you to show me the other way that we can write distributed property as well. Okay, very good job. Remember, we're just ignoring this one, right? Good, Julia. What must go in between them, in between the parentheses, is a plus sign. Okay, this should be length times width. Length times width in here. So you need to change that. Good. All right, we have rectangle A and rectangle what? B. So how many sets of parentheses did you draw? 2. And what must go in between them? Good. All right. What is the length and width of A? What is the length and width of rectangle A? Harley? Okay, we have 2 across. We got to stop at that red line, remember? And then 2 down. So we would multiply 2 times 2 to find that area. All right. If this side is 2, if my width is 2 here, I know that my width is going to be what over here? 2. Because this is a what? Okay, good. And that's important because we're about to lose those unit squares to count. okay? And then how many across? What is my length? 1, 2, 3. What is it? 6. So we would multiply what here? 6 times 2. Alright? We do our parentheses first. Emmy, what is in our first set of parentheses? And what does that equal? 4. Very good job. Bring down that plus sign. And then in our second set of parentheses, Henry Taylor, we have what? And that equals 12. And what is 4 plus 12, everybody? 16. Very good job. All right, raise your hand if you got that correct. This is not new. You should know how to do this, correct? We have done this with arrays. Very good job. All right, I'm going to erase this. And we're going to write the other way to write the distributive property here. Okay, what factor did they keep? Who's Mr. Cool Guy? I get to be outside all by myself. Who is it? 2. Okay, very good job. We don't even need that because we know I did not cut through here. There's no red line going through this 2, is it? Okay, but there sure is going in between these 2 numbers, right? So we kept the 2. Area we multiply. We have to keep that there. And so we got to figure out, we got a length, or we got a width, but we don't know our length. We cut it, okay? But it's real easy because what do you do when you put things back together? You just what? Add them. Okay, so it's asking ourselves, okay, we do our parentheses first. So what would these numbers add back to be if you count them all the way across? You have 2 plus what? 6, and that equals what?
8.
And then we bring the other number up in this case. And 2 times 8 is what? 16 square units. All right? You can look at this and know that is 2 times 8. How many of you can do that? Can you see that? Oh, I kept the 2. Nothing is running and cutting that way, is it? No, it is there. There's only one number on this side, so I know that it's 2. But there's 2 numbers up here. We cut through, so we got to put them back together. And 2 plus 6 is what? 8. So you got to look up there and know that that is 2 times what? 8. All right. Skip the next slide and let's go to this one. All right, what do you notice about this rectangle up here? What do you notice, AJ?
There's no individual groups.
Okay, what are those called on the inside? Good, there are no square units. Okay, what else do you notice? Jack? Very good job. They've already labeled these sides for us. What else do you notice, Amory? What else do you notice, Riley? They have already cut this apart, haven't they? Okay, very good job. They have already cut this apart. All right. How many squares, or how many rectangles do we have here? 2. We have A and B. So how many sets of parentheses are we going to have? 2. Remember our rule with a rectangle. Yes, ma'am? Who remembers? Opposite sides are. So we do not have a number here, right? But you better know it, don't you? All right, go ahead and label that. Why are you not filling it in? You need to be filling in your parentheses, okay? Make sure that you put them in the same order. Okay, you're gonna do 7 here first and 7 here first there. Alana, that's very unnecessary. I don't know why you're doing that. Give me your 2 sets of parentheses and fill it in. numbers. Length and width for A is easy, isn't it? They're both there, right there. Okay? What is our length times width here? Let's see. Who am I got on? Morgan, what is our length times width on A? 4 times 7. Very good job. 4 times 7. Alright, now let's focus on B. Our second set of parentheses. Length times width. Well, I have my length, it's what? 10, but there is no width there, but we know that it is what? 7, because opposite sides are equal. If this is 7, then this is what? 7, right? If this side's 7, this side is 7, okay? If this is 4, this is what? 4. If this is 7, this is what? If this is 10, this is what? This is 7, and this is what? Okay, we can also find the perimeter here. You just have to put your pieces together, right? Alright, very good job. We do our parentheses first. What is 4 times 7? I'll put it over here. 28. What must go in between them? And then 10 times 7 is super easy. What is that? 70. So add those up. This is a big number. This is why we have the distributive property. It helps us solve really big equations. Okay, and what does that equal, everybody?
98.
98 what?
Square units.
Square units. Very good job. Alright, above our rectangle, let's write the other way that we could write this equation. Okay, remember, the cool guy gets to hang out outside of the parentheses. So go ahead and write that for me. Think, who did we keep? Which factor is the present in both sets of parentheses? Who did we not cut a line through? Okay? Go ahead and write that on the top. Good, Ethan. Good, AJ. Put your parentheses around. Okay, and you got your equation. 7 times, and then we have to add those up. All right, good, Marley. Good. Who did we keep? Who gets to go outside here? 7. Very good job. Times, because remember, we're finding our original length and width, so we have to have a multiplication sentence there, right? Okay? Now, what operation are we going to have in our parentheses? Plus. We're going to have an addition here because we're bringing our two lengths together to one length, okay? We are uniting them together, okay? What is 4? Oh, sorry, I didn't mean to tell you that. What are our two lengths that we're bringing together? Marley? 4 plus 10. Okay, it's the other two factors down there that are different, right? And then when we do that, we're left with 7 times what? 14. Well, good thing we did the distributive property because I don't know what that is. Actually, we do because we just solved it. What is it? 98. Very good job. Are we feeling a little bit better about this? Okay, honestly, I have no idea if you know what we're doing or not because I sure enough can't tell by your expressions. Can you, Miss Wilcoxer? No? Okay, that's not just me. Woo! Alright, do this one. Go for it. I bet our friends at home have lots of energy. To see how many sets of parentheses? 2 sets of parentheses. Good. I see people labeling their side. They're missing the one missing side. I should not have things all over the place. Good, Bryn. I'm glad you corrected yourself on that. Good job. All right. Don't forget what must go in between those parentheses. Plus, plus, plus. Good. I love how focused Chelsea is today. Thank you, Ethan. Ethan wrote the other way that he might see that on a test. So did Eliana. Awesome. Think, who's Mr. Cool Guy? Outside. And then add those two numbers together in your parentheses. Good job. All right. We have A and B, so we have two sets of parentheses. I'm just going to put them on top of each other. It's totally fine. All right, what is our length and width for A? We only have our what? Width. Okay, we only see an 8, but that's no problem. We know that our length is what? 5. Why do we know that, Morgan? How do you know that? And what about a rectangle? What have we said? Very good job. It's a rectangle and opposite sides are what? Equal. Very good job. Okay, so what is our length and width for A? Everybody? 5 times 8. Very good job. What is our length and width for B? 5 times 2. Before I work that out, we go over here. And let's write, remember, whoever's cool that we kept. Which one did we keep? The 5. So he gets to stand out here. We're going to do 5 times something. But we got to piece together what the other something is, right? Because we broke apart our width. You can see we broke it apart into what? 8 and 2. Okay? That's a whole lot easier than the other one. We're struggling on that one, right? Everybody have both of these equations down. Okay? Think about it like this. Say, hey, we're going to go find the length and width here. We're multiplying together. I for sure know my length is 5 times length times width. Oh, I don't know my width, but I do know it's 8 plus 2, right? So that's why 8 plus 2 is in here. Okay? And then when we do our parentheses first and add 8 plus 2, we know that that gives us what? 10. So now, okay, my length and width is 5 and what? 10. Y'all are killing me today. 10. Okay? I know y'all can talk. It's like volume 5,000 at once. 5 times 10. Very good job. All right, let's solve. 5 times 8 is? 40. Plus 5 times 2 is? 10. And that's easy peasy. Our answer is what? 50 square units. Alright, this time I only want you to write it the cool way. Mr. Cool Guy over here. I don't want you to do 2 sets of parentheses. I want you to show me how would I find my original equation with your length times adding your width together. Okay? Sometimes you have your width adding your length together too, so don't get that confused, but this time you do have your length. So put Mr. Cool Guy out here, over to the side, times, and then put your parentheses. Hold on a second, I have to do those first. I have to add that up first, right? Put your hand up when you're done so I can come check you. Move your toolbar. Okay. Nice. 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 Fancy. Remember, I just want to see, I do not need to see 2 sets of parentheses right now. I just want to see the cool way. Mr. Cool Guy gets to hang out by himself. Good. I don't see anything. All right. Stop what you're doing and let's look up here because I see some people who have no idea what they're doing. All righty. Did they keep our length or did they keep our width? What did they do? They kept our length. How do you know that? AJ?
Because it's a rectangle and our length is 11.
Okay, look, if I extended this line, it is cutting through our what? Our width, 6 and 3. We see two numbers over there. So they kept what number? 11. So Mr. 11 gets to hang out over here. Your length times, let me figure out my width. We have our width, it's just in pieces, isn't it? Okay, how would I put it back together, Alana? How would I go figure out my width and put it back together? There's my width, and I have split it into 6 and 3, but I need to put it back together. How do I put that back together? What operation? Jack? Hey, I gotta add it back together, right? I've separated it, and I got to add it back together. Alright, if I went and counted those unit squares, they're not in there. Don't draw them. You don't need them, right? I would not magically get 18. We cannot multiply that, can we? All we're doing is scooting them back together, and I have 3 and 6, and now that it gives me a total of what? 9. Okay, so I don't know why we want to multiply there. We cannot multiply that. Okay, we have 6 plus 3. How many of you got that right? The ones that actually did it, you got it right. Okay, the ones that missed it were the ones that didn't even attempt it. Okay, very good job. And then when we get done with that, we have 11 times what? 9. We know that. This equals 9. Very good job. Okay, let's look right here before we go to the restroom so we can finish our lesson for our friends at home. This is exactly what we just did, isn't it? Okay, they kept what number on our rectangle? We don't have a rectangle, but we know what number they kept. What number did they keep, Eliana? Who's Mr. Cool Guy? Huh? Are you on the right one? What did they keep? What number is that? Who did they keep? 2. I thought you were saying 3. 2. I'm sorry, I can't hear for y'all's math. I know you're pointing at the right number. Very good job. They kept 2 out there, didn't they? Because he's Mr. Cool Guy. I got kept. I am your length or width, whatever one that they kept, right? We don't know. We don't have a picture of it. And then they broke apart one of the sides into a 3 plus what? Oh, it's right there. 3 plus what? 6. Thank you. Y'all can talk. Okay, good. We do our what? Parentheses first. So it told us to draw and label a picture that represents this equation. I don't know how many down, how many across until I work this out, right? So who can tell me what is our original equation here? Go ahead and solve it. I already told you the answer. So go ahead and solve this and tell me what is your original equation. What is your length and your width? Alright, we do our parentheses first. What is 3 plus 6? 9. Then we bring the other number down. So our rectangle is what? 2 times 9 equals 18. So we got to draw that, right? We got to draw a rectangle. Okay, the short side's obviously going to be what? 2. Good. And the long side's obviously going to be what? 9. Square units, because it did not tell us. Alright, you're actually going to build this with Starburst on your nearby activity later, so you would actually go 2 down, 9 across, and fill that in like we did last week. Okay? Alright, let's stop there for enrichment. So let me stop the video.